Alrighty. Let's take a look at this first one. We are given this table to look at for Juan and his gift card. And the first thing we're asked to figure out is what is the x-intercept? So what is the x-intercept here? 5, 0. The x-intercept is the point. 5, 0. It is not the word weeks. I had a fair amount of people put the word weeks for that spot. It is not the label of the x's. The x's are a unit of time if we've got time. So I'm with you, the x's are weeks, but the x-intercept is the specific point. 5, 0. Has to be the point. So when we're looking at that in context, what that means is make a sentence with it. 5 what's, 0 what's. So a good structure for that is if we're not entirely sure, say at the number from our x's, the label for the x's. So 5 weeks it's taking 5 and then the label from up here, weeks. So at 5 weeks, Juan has, or he has, how much money left? $0. That is a perfectly acceptable structure for how to do this context. At X number, X label. They have, he has, it is, whatever, some sort of preposition. X or Y number, Y label. It fits, it works. I mean, it might be grammatically weird, but it totally works. And grammar is a construct anyway, so pshaw. So you don't have to make these beautifully eloquent sentences. Give me the information, make it fit. Let's try the same thing with our y-intercept. What's our y-intercept going to be? 0, 50. It's a totally separate point. And it is a whole point in and of itself. We know that our x value is 0, so our y value is 50. So what is that in context? How would I put that in a sentence? Perfection. At 0 weeks, he has $50. You could also do, he starts with $50. The gift card originally had $50. At week 0, he has $50. It all means the same thing. It's just a matter of whether we're doing kind of a plug and chug situation or if we think it in a slightly different way. So it doesn't matter if your sentence is pretty. Just get the information to me. So these kinds of structures where you have your X number and then the label from your X's and then the Y number and the label from your Y's totally works. Use the information available for you. Let's look at the next one, number 2 down here, very bottom. What do we do with this? Well, I'm going to change the view just because it's very small and very low. What the heck do we do with this one? Combine like terms. I've got a couple of like terms in here. I've got 7c and minus 7c. What happens when we combine those together? They cancel out. We get no c's. So we're left with 3 equals 5. This would 100% be no solution. Because 3 does not equal 5. Never, ever, ever, no matter what c is. C can be 12, C can be 500 million. 3 does not equal 5. It just doesn't. If you get something that is true, like 5 equals 5, that's when we have infinitely many solutions. Because that works no matter what happens. So if we get something that's false, no solution. If we get something inherently true, all the solutions. Okay? Questions on these 2 questions? There's really kind of 3 questions. Okay. So we're going to be on the very last page of the notes packet here. Oh, snap. What? Oh my gosh. Look at us getting close to the end of this chapter. Ah. And today is really going to combine things together. This is going to take all the things we've done so far and smush them together into draw a pretty picture. When we are graphing, you do want to use pencil because there are going to be times when you need to, I don't know, erase. I have some whiteout, but the whiteout I have takes time to dry, so don't do it in pen because it makes it really hard to keep going. If you ever need pencils or a writing pencil of some sort, I keep some in the back over there by the pencil sharpener. You are welcome to use them. And if it runs out, let me know. I have a stash. I can't fit all like 800 pencils that I have out at the same time. So we're going to use pencils when we're graphing. And whenever we're graphing, I want us to go as far as we can on the boxes. Do not draw me teeny tiny little baby graphs. I will show you as we go examples of some really bad graphs, things I've seen before. And then I'll show you good ones. Okay? So we're going to get, with these graphs here, and you can see on your page, a list of information that we're going to use to give ourselves a sketch. We are not doing proper graph. We have no equation. We're not plugging in values. We are not making a table. We're using the stuff in the list to get the vibe of a graph. It is a sketch, not a proper graph. We're getting the vibe, but we're going to get as close as we can. So we're just going to take all the pieces we have here and kind of run with it. So let's see. We've got a y-intercept at 0, -4. So I'm going to plot that point. 0, -4 is that guy. Then we have our x-intercept, which is going to happen at 2, 0. So 2, 0. The next line says it's linear. So what is this going to look like? A straight line, which means we should use a ruler. Oh, shock of all shocks, there's rulers at your table. What? Oh my God. If you need more rulers, let me know. I have more. There's also some cups on the edges that have some more rulers. So this means we use a ruler. If we have a statement that is linear, you need to use a ruler. But at that point, it's not telling me much other than that I need a ruler. The next line says it's continuous. So that just means when we're drawing it, we're not going to pick up our pencil when we're doing it. It's going to go from one end to the other without me picking up my pencil. And then our last piece we're given up here is our end behavior. We talked about this yesterday. This is where we have our x approaching -infinity, which means we're looking at our left arrow here. And our f of x, remember that's y in disguise, approaching -infinity, which means which way is that left arrow going to point? Up or down? Down. -infinity means it's going down. So my left arrow is pointing down. So somewhere down over here, we're going to have a down arrow. When I'm putting end behavior on here, I'm always just going to go a little bit outside the leftist dot we have for my arrow. And our right arrow, because this guy talks about my right arrow, points which direction? If f of x approaches +infinity. Up. So my left arrow points down, my right arrow points up. So again, I just go a little bit outside of my rightist dot to kind of figure out where to put my arrows. It's not perfect, but it gets kind of the vibe, and we can see what we're going to need to connect up because we're going to play connect the dots. I need to connect my arrows to my 2 dots with a ruler because this one is linear. So you're going to use a ruler. My screen's going to get grumpy with me if I get it too close because it thinks it's made up of 1,000 fingers. So you're going to use your ruler and you're going to connect your 2 lines. And yeah, my arrows are a little bit off of where they're going to need to be, but that's okay. I'm going to draw new ones on my line. It's just so that we see what's happening. So use your ruler, connect them up, and go to the edge of your graph. It should look like this. Do not draw me a line like this. This is bad. Good. Bad. Good. Bad. always have somebody that tries to draw their graphs as possible. Don't do that. I can't read it. Big. I am old. Give me big graphs. Think large print. I am almost 40. Big graphs. Give me as much as you can. So don't draw teeny little baby lines like this. Even if you're crossing two axes, don't draw me teeny lines like this. Go from edge to edge as much as you can. Okay? With our sketches, we're getting kind of as much of a vibe as we can. We're using all of our information, and we're calling it good. Questions on this one? Because that's your sketch. How's that? Boop. Let's look at the next one. Same kind of vibe. We give you a list of information. We're going to use it kind of like a checklist as we're putting stuff together. We're going to take all those pieces and draw them on our graph, and then when we get to the end, we'll connect everything up. So we have lots of pieces here. Again, if you ever want colors so that you can kind of color code things, please let me know. I have a gabillion colored pencils, markers, highlighters, whatever you need. Always happy to get them out. They are in easy to grab bins. So if you ever want them, I can grab them for you. No problem. So we're going to put our y-intercept up here. Y-intercept at the point 0, 3. So my x is 0, my y is 3. That's this guy up here. We know it's going to be continuous. We like that. Then we don't have to pick up our pen. It's nonlinear, so I don't need to use a ruler. I can use it for parts if I want to, but I need to make sure it's not just a line. We have our absolute minimum at -4, -2. So I'm going to plot that point, -4, -2. And if I have something that is an extrema, especially if I have an absolute, I'm going to label that as my min so that I know when I'm connecting stuff up, I don't want to go lower than that. Because that's my absolute minimum. That needs to be the very bottom ever. So I don't want to ever go below that point. So I label it. You don't have to, as long as you remember that that's your absolute minimum. I cannot go lower than that, or I've changed the absolute minimum. Our next piece we have in our list here are our x-intercepts, and in this case we have 3 of them. So we have -5, 0, we have -3, 0, and we have 4, 0. And we can start to see that this is a wiggly, squiggly, weird looking thing. But that's okay. We can deal with that. We have one more piece to look at in here, and that's our end behavior. So if we look at this one, they switched our order on us on this one. They gave us the positive infinity first. That's okay. We just need to be careful and paying attention. That'll happen every now and then. Because this one means when x is approaching positive infinity, as x gets real big, that's looking at our right arrow first this time. And which way is our right arrow pointing? Up. It's going to positive infinity, so my right arrow is pointing up. So again, to kind of sketch in my arrows, I find my rightest point, because I've already been through all the other pieces, and I'm just going to put it a little bit righter than the rightest point. So I'm going to put my up arrow here-ish. I am not going to judge about where you put your arrows, bless you. I'm just put it there because then it's easy for me to see and know what I'm talking about and connect them up. So then let's look at the other one we have over here, which is as x goes to negative infinity, which is going to be our left arrow. Which way does that point? Also pointing up. So when I'm putting that arrow up here, I'm going to find my leftist point, and I'm going to go a little bit left of that. So I'm going to put it here-ish. Again, you don't have to do that with the arrows. I just find it as an easy way to kind of put them down. So then what we're going to do, now I've got all the information. Absolutely everything's up there. It's continuous, so I'm going to start from one end and go to the other and not pick up my pen. And it's nonlinear, so I don't need to use my ruler. So I tend to go from left to right. Important things to know is I cannot make any new x-intercepts. We already have how many they are. And I know the lowest I can go, which is right here. As long as I connect things up, I keep it a function, so no loop-de-loops. I can make whatever kind of kooky shape I want. So I'm going to show you several. Kind of the most basic one, the one that most people will go, is going to be something like this. Connecting things up, hitting all our points, and connecting to our arrows. That is probably going to be the most common answer, something that looks like this. Not the only option. You can go all kinds of places, except not like that. You can go wiggle squiggle. We've got a minimum here. I can go like this. You can go all kinds of places. Creative choice, driver's choice. That technically has all the same pieces. It's crazy looking, but it has all the same stuff. You can go all kinds of wiggle squiggle crazy. Just don't do any loop-de-loops because then it's no longer a function. It fails our vertical line test. Let's make a cool roller coaster, just no inversions. The most common one's going to be the first one that I showed you, where we have to go to the 4 and then back up, because we need to wind up with those up arrows. So just don't give me any extra x-intercepts, because we already gave you how many there were. Get rid of those 3. And don't go below your minimum, and you're probably fine. Okay. Questions on this one? Because again, we are not properly graphing these. We're getting a sketch. We're getting the vibe. We got one more. This is the last thing in the packet. Oh my gosh, we're almost done with that. I know, so exciting. All right. So this one's a little extra, but that's okay. We can do it. Same kind of vibe. Start the exact same way. We've got our y-intercept at 0, -2. So 0, -2 is that guy right there. We've got our x-intercepts at -4 and +3. So -4, +3. This time it says it's not continuous. So we are going to need some sort of hole or jump somewhere. Either it's got a break in the line where I've got 2 separate looking pieces, or lava pit to jump over with a little hole. Either way, that will make it discontinuous. And it's also nonlinear because it's also not continuous, so it's going to be nonlinear. And then the last piece of information that we're given is our end behavior. So let's put that up. So we've got our x going to -infinity, which talks about which arrow? Left or right? Left arrow. Which way is my left arrow pointing as it goes to -infinity? Down. So my left arrow is going to point down. So we're going to have a down arrow over here somewhere. We also have this one, which if the first one talked about a left arrow, this one's going to talk about our right arrow. Oh my gosh, look at us. Which way does our right arrow point? Up. I love it when we have an idea with sound effects. So much fun. Ding. Like you could hear the light bulb. So our right arrow is going to point up. So again, I just go to the right of my rightest point and I put the arrow there. You don't have to do that. I just feel like it keeps things tidy that way. I've seen people that will draw their end behavior like this so that they don't have to worry about it. It covers the whole thing. But it's just going up. It's going up on this side. However works for you. If you don't want to have it on your graph and you just like to think about them over here, that's totally okay. I'm looking at your picture. I'm looking at the end result. So let us put this together and connect it up. So I need to go through my x-intercepts here, each of them, and through my y-intercept. So I'm going to come here. I know I've got this y-intercept down here, so I'm going to go bounce off that guy, through here, and up here. Usually about here, someone goes, oh shoot, it's supposed to be discontinuous. Hole. That works. It is discontinuous. If I trace along this, I have to jump over the lava pit to finish it off. I had to pick up my pen. That counts. You can even, if you've drawn the whole thing, you can go, oh, shoot, I forgot to put a discontinuity, and you can put one in there. That's when it's really, really helpful to have, a pencil, because you can then erase that little bit inside. Otherwise, you have to get the white out, and you have to come in here and do this, and then you have to wait for it to dry for forever to get rid of the little line in the middle. Okay, so that makes a discontinuous function. That is definitely an option. Not the only choice. I'm going to show you a couple of ways you can draw this. Because the other way I see is that someone will go through this line and go, oh, shoot, how do I get back down there for the y-intercept? And I'm going to go, well, poke a hole, start over. Also works. Meets the same requirements, has the same x-intercepts, has the same y-intercept. Discontinuous. Totally works. You can get all kinds of creative freedom on this one. You can do all kinds of stuff. You could go all kinds of hog wild. Poke a hole here. Squiggle, squiggle that way. You could have a hole on that one. All kinds of choices. This one has so many options. I do feel like something like this is kind of the easiest option, but by far not the only option. So when we're looking at these sketches, we don't have enough information for it to be perfect. So the likelihood of yours exactly matching mine or exactly matching your neighbor's is incredibly low. There's going to be some similar pieces because they all have the same x and y intercepts, but they're not going to be identical. They just aren't. Because we're making it up. We're making an educated guess. We know some stuff. We do not know everything. But we're making a guess. Okay, so just make sure we fill as much of our graph as we can. Go from edge to edge. Try and fill in as much information. Questions on this one? This is probably the most annoying one. Okay, so what I'm going to give you guys now is the review for the quiz. I'm not giving you a separate homework with sketching on it because we have a quiz coming up on Thursday, and I'm not going to give you homework and a review on the same day because that's mean. So in the review, there are 4 sketches so that we can practice that. So it's kind of combining the homework and the review together. It's on there. So if it's covered on the quiz, it is covered in the review. I do not guarantee everything in the review is on the quiz, but everything on the quiz is on the review. So I'm going to give these out to you guys, and then I'm going to pass back like the skills check and stuff and all the homework stuff that I have for you guys. And you guys can work on this. And tomorrow we'll work through some problems together, and we can ask questions, we can work through things, but getting ourselves ready for the quiz coming up on Thursday over everything we've done so far this year. Here's these. Pass them down. And I do give you guys points for reviews because it's a lot of work, and I want to make sure, essentially how you get paid for doing work in school. You turn in homework, I give you points. It's a pay scale. So you'll turn them in at the start of the period right before you take the quiz. I'm not going to take them before the quiz. When you start the quiz, turn it in. Or when you come in that day, turn it in. That way, I can give you points for it because you do a lot of work on these. So we'll talk through some questions you guys have on it tomorrow, but now's a great time to get started. I'm going to pass back everything I have from you, and just let me know if you have any questions. I'm happy to help.